Good day, class. Today we're going to go over some notes, and we're going to go into notes particularly pertaining to the notes of properties of functions and function behavior. Now, I'm going to need you to go ahead and get out your paper, and you're going to write all this down because these definitions are important. I want you to be able to look at these definitions, then look at the work we're going to do, and then revert back to the definition and make an understanding that you understand the mechanics behind each of these definitions. Now, one of the first things we're going to talk about with function behavior is going to be talking about an increasing function. Now, go ahead and write this down. I want you to go ahead and write down that an increasing function is an open interval on which as x increases, y increases. And when we go to the graph, it'll make a little bit more sense. So go ahead and write that down. And then I also want you to write down this definition, decreasing. Decreasing is an open interval on which when x increases, y decreases. And again, we're going to go through how this is going to look in a graph. And lastly, let's talk about a constant. A constant is when an open interval on which as x increases, y remains the same. So what I'm going to go ahead and do now is I'll pause the video, and I'm going to give you time to go ahead and write this down. And then after that, we'll go ahead and revert back to it. So I'll go ahead and pause the video now. Okay, great, class. Now that you've had time to write these definitions, let's actually go ahead and look at a function and identify the increasing, decreasing, and constant behaviors of this function. So let me go ahead and show you this function, and the same thing, I want you to go ahead and copy this. So I want you to go ahead and graph this. So I'll go ahead and give you a little bit of time to go ahead and graph this. I'll pause the video again to give you time to graph this. Okay, now that you have graphed this, let's go ahead and talk about the increasing, decreasing, and constant features of this function. Now, one of the things we're going to do is we're going to go ahead and label, and we're also going to put down the intervals of this function where it's increasing and decreasing. Now, the first one, I'm going to go ahead and start from left to right, but I want to go ahead and point out that on this function, we're increasing from somewhere over here. This function it starts from over here from negative infinity. So this part of the function is increasing. So go ahead and write this. Increasing. And it increases up to this point that's right here. So if I was going to go ahead and write down the interval for this one, I will go ahead and state that I start from negative infinity and that my increasing function stops. Let's see, it stops at about negative 2.75. So negative 2 3/4 is where my function stops. But that whole part of that is increasing. Now let's go ahead and talk about the next part of this function, which is decreasing. And before I move on, I wanted to go ahead and show you the definition of why increasing, decreasing. Now if you look at your notes should be saying as x increases, y increases. That's what this behavior right here is exhibiting. Look at this function. As x increases, so does the y. So now let's talk about decreasing. Decreasing follows not the opposite, but just slightly different definition, which means that as x increases, y decreases. So let's go ahead and show you that on paper how that looks. Okay. Let me bring this up so y'all can see that a bit better. And what I'll do is I'll change the color for decrease. Decrease, and I'll make it blue. So, actually not blue. Let me change it to purple. Okay, so this is decreasing here. Okay. Now, in this decreasing function, one of the things we're going to go ahead and write down is also that at the points where it stops decreasing, which is about here. This is the point where it stops decreasing. And if I was going to write the interval from there to there, I would go ahead and write this down. I'll write down that I go from where I stopped at, negative 0.275, and it goes to about negative 0.5. Okay, so there's my decreasing function. Now the next part of this function, it's not surprising, but it's increasing. It's only increasing from here to here. So I'm going to go ahead and write down increasing. I'm just going to make a acronym, INC. And I'm going to go ahead and put that in the interval for this one. Now the interval for this one is going to go from 0.5 0.5 where I left off, negative 0.5, and it's going to stop at about 0.75. And then from there, function goes ahead and decreases again. So let me go ahead and take out my purple color and write decreasing, because as x is increasing, the y is decreasing. That's the reason why it's a decreasing function. So let me go ahead and write my lowest point there. And in this case, my decreasing function for this one is going to go from 0.75 to about 3. And lastly, function increases, so it just shoots right off. Now for this one, I'm going to go ahead and write down increasing on this side. And the interval. Now for the interval for this one, it's going to go from 3 to about infinity. So in here, if you notice, there was actually no constant as far as our function behavior. Everything was either increasing or decreasing with this function. So let's go ahead and move on to the next thing that we're going to be working on. And we're going to go ahead and talk about local minimums and maximums. And let me go ahead and read the definitions, and I have you copy them down. The local maximum is the value of y of a peak in your graph. And the local minimum is the value of the bottom valley in your graph. So then after that, I'll have you practice, but I'll go ahead and give you time to write this down. So let me go ahead and pause the video. Okay, great. Now that you have written that down, let's go ahead and look at some examples in regards to identifying some local maximums and some local minimums. And here we are. We have the same graph as before. And one of the things we're going to go ahead and realize is that you have a couple of maximums and minimums here. Now let's go ahead and identify the maximums. The maximums are the ones that have the highest points, kind of like the top of the hill, and whereas the other ones are kind of like the bottom of a valley. Now which ones look like you're in the top of the hill? Right here. Let me go ahead and point them out here. Here's a maximum. Here's a local maximum. All right, go ahead and write down local. Here's another local maximum here. And after that, you're going to realize that we've run out of local maximums. Now, one of the things that I'm realizing is I probably didn't give you time to draw this graph. So let me go ahead and pause it to give you time to draw this graph. And then I'll go ahead and we'll continue with this. Okay, great. Now that you've gotten time to go ahead and draw this, let's go ahead and specify where we have our local maximum. Now, local maximum on this one is going to be negative 2.75 for the x, and then the y is roughly about the same place. Well, not the same place, I'm sorry. It's in the y value on this one is 2.75 in the positive. So there's my local maximum for that one. Now let's look at the next one. The next one, the local maximum, it's roughly about 0.75 for the x and about 0.5 for the y. So there's my point for that local maximum. Now let's go ahead and identify the local minimums. Now for this one, there's only 2 local minimums, which is this one here. There's my local minimum, and then here, right over here. Here's my next local minimum. So let's go ahead and then write down these local minimums. Now for this one's going to be negative 0.5 and roughly negative 0.5 as well. So there's my point from my local minimum. And for this one over here, for this minimum, let me go ahead and write down 3 and negative 3. Great. Now, we went ahead and found out all our local maximums and also all of our local minimums. So let's go ahead and move forward to the next part of this. So we can go ahead and talk about something that's important with functions. And this is one of the things that we need to determine as far as functions. And we need to go ahead and determine if something's odd or even or neither. Now, there's a couple of ways to go ahead and find this out. And let me see if we did this here correctly. Oops, a little too further out. Okay. Now, there is something that I need to show you, or I want to show you, as far as writing down some definitions in regards to this. So let me go ahead and tell you. Let me take a blank sheet and write this down. I want you to go ahead and write this down too, which is, how do you test if a function's even versus or odd? So let me write that down. I want you to write this down. Even or odd. This will kind of be your title of it all. Now, this is how you test for even. So if we have a test for even, it's going to be done in this particular manner. One of the things you're going to have to do is make the f of x negative. Now, if your resulting answer comes out being f of x, which was your original equation, then that means that you have a graph that is symmetric to the y-axis, which means it's even. And so it's really just symmetry. I'll go ahead and fix this. I like the way that came out. So, okay. Alright, so let's go back and write down this word symmetric. Okay, so symmetric to the y-axis. Now, let's go ahead and talk about the test if the function is odd. Now, this is what occurs. Now, let me write this in a different color. So, test if for odd. This is how a test for an odd function looks like. It's going to be done in such a manner that if you go ahead and do the same f of negative x, your resulting answer will actually be negative f of x. So, and if you get this, you get something that is the graph. An odd function, you identify it, in our case, is symmetric to the origin in this case. So, symmetric to the origin. And that's how you tell if something is... These are the two tests for even and odd. So we're going to go ahead and apply these two tests when it comes to determining our last function, if it's even, odd, or neither. So let's go ahead and talk about the first one. Now, one of the things I'm going to go ahead and do is I'll pause the video because I want you to go ahead and write all this in. So let me go ahead and pause the video now. Okay, now that you have written all this down, let's go ahead and do determination if it's even. That's the first one we're going to do. Now, to determine if it's even, we're going to apply this test to it. And go back to red, color red. I'm going to go ahead and apply this test. F of negative x, if it equals f of x. Now, in order for me to go ahead and do that, means that I'm going to take my function, which is the one on top, and I'm going to apply the f of negative x. So f of negative x applied to that function will look something like this. 3 to the negative x cubed plus 5. Now, I'm going to go ahead and continue the simplification process. So f of negative x. Now this being cubed means that there's really a 1 in front of here. Now, negative 1 cubed. Okay, means I have negative 1 times negative 1 times negative 1 times negative 1, which will result in a positive 1. So for this case, I go ahead and actually, I'm sorry. Actually, let me go revert back. I know probably some of y'all went ahead and caught the mistake. Negative 1 times negative 1 times negative 1 is really, I'll make it in red, negative 1. Which means that this function stays, well, the negative x cubed part stays negative. So in my case, I'm going to have negative 3 x cubed plus 5. Which means that this function does not look like my original function. And because of that, it's not even. It's not even because f of negative x is not equal to f of x. So which means it fails a test, it's not even. So let me go ahead and give you a little bit of time to write that down. Now, let me go ahead and erase this because we're going to do the next test, which is the test for the odd. So go ahead and erase all this here. And test for odd. So now let's go ahead and find out if it's odd. Now, in order to determine if something's odd, I have to go ahead and use the test for odd, which means that if f of negative x is equal to negative f of x, then I have a function that's odd. Let's go ahead and see that. Let's go ahead and determine if that's true. So let me go ahead and do the same thing in regards to defining to see if it's odd. And one of the things you could realize is you could apply this either way. Either you could apply it through, let's go ahead and apply this. Let me go ahead and pause the video for a second because I want to see something on how we apply this odd function. So hold on a second. Great. Now getting back to our odd function, one of the things we want to keep in mind is that in this case, we already know what f of negative x equals. So we're going to go ahead and do the other side and see the equal to make sure this is odd. So let's go ahead and write down what f of negative x equals. So you probably have written it down already, but I'll go ahead and write it down since I erased it. Now our original one, f of negative x, actually equaled negative 3x cubed plus 5. That's what it was. So in our case, we're going to go ahead and compare this with whatever results off this here. So let me go ahead and apply that. What we're going to do that negative to the function, and then from there make the determination and see if they're equal. So let's go ahead and do that. So negative f of x means that I apply a negative to the 3x cubed on the other side of the function. Now the only thing I have to do here to simplify is go ahead and distribute the negative. So let me go ahead and distribute the negative. Negative gets distributed there. And here, which means that I go ahead and result with this kind of answer. Negative f of x is equal to negative 3x cubed minus 5. Now that I have that here, I could go ahead and compare this one with this one. So make a comparison. And the comparison clearly says, says that they're not equal. You know, and so one of the things that we're going to say is that it's not odd. It's not odd because the fact that f of negative x is not equal to negative f of x. So in this case, since we determined that it's not even, it's not odd, one of the things we're going to realize that it's actually neither in our case. So this function is, write that down, is neither. Okay, great class. All right, let's go ahead and start working on whatever work we need to work on. And remember, tomorrow we're going to be having our first quiz. Okay, great. Thank you for watching this.